Very good morning, children. I am K.C. Hubbali, PGT Chemistry, Jawahar Navodaya Vidyalaya, Uttar Kannada, Karnataka State. Welcome to this class. In this class, we shall learn about one of the important chapter in organic chemistry. That is nothing but aldehydes, ketones, and carboxylic acids. So, in the CBSE board examination, this chapter carries 6 marks. So, very important concepts are there in this chapter. We shall learn this chapter into 2 parts there. One is about aldehydes and ketones, and other part is about carboxylic acid. So in this class we shall concentrate only on this aldehydes and ketones. What are aldehydes and ketones? You have studied in lower classes also there. Aldehydes are the class of organic compounds containing the CHO as the functional group, whereas ketones are the class of organic compounds which contain C-double-bond-O as the functional group. This carbonyl group is present in case of these compounds there. So, in addition to this, other compounds are also there which also contain the C-double-bond-O carbonyl group. So, they are all listed here. One is aldehydes. This is general representation for aldehyde is RCHO. We write C-double-bond-O and H. It is written like this. Ketones are the class of organic compounds containing C-double-bond-O as the functional group. This ketonic group is bridged between 2 alkyl or aryl groups. Carboxylic acids also contain the C-double-bond-O carbonyl group. So one side alkyl group is there, other side OH group is there. In case of acid amides, acid halides, so one side R group is there, alkyl or aryl group, other side halogen is there. So this carbonyl group is bridged between these 2 groups. In case of esters, carbonyl group is bridged between one side alkyl group, other side this OR dash group. In case of acid anhydrides, so carbonyl group, there are 2 carbonyl groups here. Okay. So that is bridged between one oxygen, 2 carbonyl groups are present like this. So acid anhydride we call it there. And the other one is this acid amides. In case of acid amide, carbonyl group C-double-bond-O group is bridged between one alkyl group and other side amide group. Like this, we have this aldehydes and ketones. In addition to that, some compounds which contain the C-double-bond-O group. All these compounds are collectively called as carbonyl compounds. So these aldehydes and ketones are very, very important compounds in our daily life activities. They are widely spread in plant and animal kingdom. So they play an important role in the biochemical process of life. So they add fragrance and flavor to the nature. They are very pleasant fragrances. So like this we have the so many applications in our daily life activities. So in this chapter we will be learning about part like this. First is about the nomenclature. Second part is about the methods of preparation of this compound. Third part is about physical properties. Fourth part is chemical reactions and chemical properties. And the fifth part is about the uses of these compounds there. So let us go to the nomenclature of these aldehydes and ketones. How to name these compounds? What's the common name? What's the way in which we name in the common system? What's the way in which we name these compounds in IUPAC system? That we are expected to know it. Let us go for the nomenclature part. So let us look into the simple examples. We will start nomenclature with simple example. The simplest aldehyde is SCHO. It is SCHO. Commonly this is called as a formaldehyde. And the IUPAC name for this one is a methanol. So this should be taken name as alkanals. Alkanal. So alkane, so depending upon the number of carbon atoms present, we name alkanes. So methane, ethane, propane, butane, like that. So that E you replace by al depending upon the number of carbon atoms present in that compound. So name these compounds there. So first compound is a CHO, which contain only one carbon. So one carbon containing alkane is a methane it is. Here it is a methanol it is. Alkanal, common general way of naming is alkanals it is. Right. So second compound is CH3CHO, commonly called as acetaldehyde it is. And since it contains two carbon and aldehydic functional group, so ethanol we call it there. Third compound is CH3CH2CHO, 3 carbon it contains. 3 carbon containing compound is a propane. So propanol we will call it in IUPAC system, and in common system it is propanaldehyde we call it there. Fourth one is you have a branch here attached to the main chain. So CH group is linked to the middle carbon there, and either side we have the two CH3 groups like this. Isobutyraldehyde we call it. Isobutyraldehyde we call, and the IUPAC name for this one is 2-methyl. This is first carbon, second carbon. To the second carbon methyl group is attached 2-methyl propanol we call it. Another one CH3, CH2, 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 CHO, pentaldehyde, and a pentanal we call it there. So pentaldehyde we don't call it, valeraldehyde also will call it there. And another one is this compound containing cyclohexane ring, and to which the CHO group is attached, and third position of this methyl group is attached. So the system of naming is like this. This is first carbon, this is the alpha carbon. Carbon to which the functional group is attached is alpha carbon it is. Next carbon is a beta carbon, its next carbon is a gamma carbon. So to the gamma carbon CH3 group is attached, so therefore gamma methyl it is. And cyclohexane to which the carbaldehyde group is attached there, therefore naming system is like this: gamma methyl cyclohexane, gamma methyl cyclohexane carbaldehyde, carbonaldehyde or carbaldehyde. Okay, so IUPAC system it is 3-methyl, third carbon methyl group is attached, 3-methyl cyclohexane carbaldehyde or carbonaldehyde. That's how we are going to name it there. Look into the other one. So if this this is not there, it's simple aldehyde or aromatic aldehyde, that's nothing but a benzaldehyde it is. So to the third position, third carbon, this Br group is attached there. So adjacent position of the functional group attached is ortho position we call it. This is meta position, para position. To the meta carbon Br is attached, meta bromo benzaldehyde we call it in the IUPAC, in the common system. In the IUPAC system it is a third position, therefore it is a 3-bromo benzaldehyde it is. So there is one more aldehyde here, in which the two aldehyde groups are attached to the benzene ring. So adjacent to each other, 1 and 2 positions only, therefore benzene 1,2 carbaldehyde it is. That's how we should name it there. So benzene 1,2 carbaldehyde we call it, or commonly this is called as a phthalaldehyde it is. Let us name some more aldehyde like this: CH3, CH2, C double bond O, CH2, CHO. So this ketonic group, oxygen attached to the third carbon here. So 3-oxo we call it. So this compound, this main chain contains 5 carbon, and at the end aldehyde group, pentanal it is, but third carbon is having this oxygen attachment, therefore 3-oxopentanal it is. Another compound is to the benzaldehyde, the nitro group is attached to the fourth carbon, 4-nitro benzaldehyde it is. We have one more very important compound. Look into this. 1, 1, 2, 3. First carbon, third carbon and second carbon. All the 3 carbon attached with this aldehyde group. So naming system is like this. Propane it is. This should be taken as a derivative of propane only. Propane 1, 2, 3, tricarbaldehyde it is. That's how we should name. I repeat once again. Propane 1, 2, 3, tricarbaldehyde it is. That's how the aldehydes are named. You can just go through some more examples from the textbook. Okay. So let us see how to name the ketone. The simplest ketone is containing 3 carbons there because that carbonyl group is bridged between 2 alkyl group in case of ketones, 2 alkyl or aryl group. So the simplest alkyl group we can place on the either side of carbonyl group is a methyl group only. 2 methyl groups are present on either side and at the center we have the ketonic group. So this is the simplest ketone. The simplest ketone contains 3 carbon. Common name for that one is acetone it is. And the IUPAC name for that one is since it contains 3 carbon ending E you remove from propane, propanone it is there. Alkanone, naming system in the case of this is alkanone it is. General naming is alkanone it is. So propanone it is. Okay, next example you see there. CS3, CS2, C double bond O, CS2, CS3. In the chain 5 carbon are there. So definitely pentanone it is. And third carbon is attached with oxygen. Therefore, that is ketonic group is present at third position. So 3 pentanone it is. 3 pentanone it is. That's how we should name it. Or pentanone 3 won't, but 3 pentanone we will name it that. Right. So and this is common system for that one is this side ethyl group, this side ethyl group. So diethyl ketone it is. It's named as a diethyl ketone. Well children, in this class let us learn some more example of naming this aldehydes. So here you see this example CS3, CS2, C double bond O, CS2, CHO. Third carbon attached with the oxygen, 3-oxo we call it. It's a compound which contains 5 carbon and aldehyde group. That's for pentanal it is. 3-oxo pentanal it is. And another example, benzaldehyde to which nitro group is attached to 4th person. So 4-nitrobenzaldehyde. That's how we will name it there. And another example, which is an important one. Look into this. How to name this? So first carbon, second carbon, third carbon attached with the aldehyde group at all the positions. Therefore, propane 1, 2, 3. Propane 1, 2, 3. Tricarbaldehyde. That's how we will name it. So like this we can name the aldehydes and aldehydes. Just go through some more example from the textbook and try to name P mastery in naming aldehydes there. Now let us go for naming these ketones there. How to name the ketones there? The simplest ketone is nothing but acetone it is. It's a ketone which contains 3 carbon. Carbonyl group is bridged between 2 alkyl group it is. 2 alkyl group, simplest alkyl group is methyl group, 2 methyl group are present on the either side of ketonic group. So this is the simplest ketone. Common name for that one is acetone it is. IUPAC name is ending as ONE. They are named as alkanones there. Alkanones. Okay. Since it contains 3 carbon, propanone it is. Like that it is. So another example, CS3, CS2, C double bond O, CS2, CS3, third carbon attached with a ketonic group. 3 position, third position is having own group. That is why 3-one it is containing 5 carbon. Pentan 3-one it is. Pentan 3-one. Like that it is. Common name for that one is, this is one ethyl group, this is one ethyl group, this is ketonic group. So diethyl ketone it is named as a diethyl ketone. Another example you see there CS3, CH, CS3, C double bond O, CS, CS3, CS3 it is. So this is isopropyl group it is, and this is also isopropyl group linked. Both the isopropyl groups are linked to the carbonyl group. Therefore, diisopropyl, two isopropyl group linked to the ketonic group, diisopropyl ketone it is. That's how named in the common system. In the IUPAC system, it is named like this. So we'll number carbon chain like this: 1, 2, 3, 4, 5 like that. Third carbon is carrying this ketonic groups. That means it should be named as a 3-one. Second and fourth portions contain methyl group. Therefore, 2, 4 dimethyl pentane 3-one it is. Naming is 2, 4, or from this side 2, 4 pentane 3-one it is. That's how we will name it. So among the aromatic ketones, the simplest aromatic ketone is this one, methyl phenyl ketone. Methyl group, phenyl group, ketone. Or we call it the acetophenone. Common system also will call it the acetophenone only. Okay. So two phenyl groups are present in the next example. This is C6H5, one phenyl group, another C6H5 group attached to the ketonic group, diphenyl ketone it is, or benzophenone it is. Commonly in the IUPAC system it is called as a benzophenone. This is how it will be named. Well, in this class, in this part, let us learn about the methods of preparation of this aldehydes. So first one is from the oxidation of this alcohols. Alcohols, you know that primary alcohols on oxidation give the aldehyde, whereas secondary alcohols gives the ketones there. That method you have studied in the junior class there. So hydration of alkenes. Alkenes on hydration, so gives alcohols in the presence of concentrated sulfuric acid. Third method is the ozonolysis of hydrocarbons there. So ozonolysis is a process in which ozone is added across the double bonded compounds. When ozone is added across the double bonded compound, ozonide is going to be formed, which when heated with a zinc forms the aldehydes there. This method also you have studied in the 11th class syllabus there. Another one is the hydration of alkynes. Alkynes when undergo hydration, so you will be getting aldehydes. So these are the common methods by which you can prepare aldehydes and ketones there. There are some special methods by which you can prepare aldehydes and ketones. First one is the Rosenmann's reaction, that's from the acid halides. Acid halide when heated with palladium, hydrogen and barium sulfate, so you will be getting aldehydes there. That method is called as the Rosenmann's reaction. Process is called as the Rosenmann's reaction. Similarly, we can also prepare aldehydes and ketone from this nitriles, cyanides and this esters. So cyanides when treated with this stannous chloride in the acidic medium forms this compounds which are hydrolysis, you are going to get the aldehydes there. Okay. So this reaction is called as the Stephen's reduction. It is hydrogen adds across the triple bond of this cyanide group, then subjected for hydrolysis, you will be getting aldehydes there. That is called the Stephen's reduction. It is. So cyanides, from cyanides you can also get this aldehyde by treating that one with cyanides with this diisobutyl aluminum hydride as a reducing agent, followed by this hydrolysis, you will be getting aldehydes. Similarly, you will also get aldehydes from esters. Esters also when treated with this diisobutyl aluminum hydride, you will be getting, followed by hydrolysis, you will be getting aldehyde. That's how you can prepare this aldehydes there. So another method is from this hydrocarbons. Hydrocarbons, very important method to prepare this aromatic aldehydes especially. First one is oxidation with chromyl chloride. So when treated with this toluene, when treated with the chromyl chloride followed by hydrolysis you will be getting a benzaldehyde. This reaction is suggested by the scientist Aldehydes, known as the Aldehydes reaction it is. Another one is from alkyl benzene only on oxidation with KMNO4, whether it is a methyl benzene or ethyl benzene or propyl benzene, whatever it is, on oxidation you are going to get a benzaldehyde. And third method is from alkyl benzene only when treated with this chromic anhydride, chromic oxide, and in the presence of acetic anhydride followed by hydrolysis in the acidic medium, you will be getting benzaldehyde. Another one is a Gattermann-Koch reaction it is. So benzene when treated with carbonyl group in the acidic medium in the presence of anhydrous aluminum chloride, you will be getting a benzaldehyde. You will also get, this reaction is called as the Gattermann-Koch reaction it is. You will also get from alkyl benzene and chlorination followed by hydrolysis also, you will be getting a benzaldehyde. So these are the methods by which you can prepare these aromatic aldehydes there. So this is how aldehydes are prepared by different chemical reactions there. So let us see how ketones are prepared.